Hello, hello. It is week 10 of ME250. Of course, we're going to consult the handy dandy CAD calendar to see what we're going to do this week. And we can see we're going to do 15, 16 part drawings and dimensioning. So it should be a pretty simple week. We're not going to be creating a physical part. We're going to be creating this entire document right here, the engineering drawing. So this part itself is an old practice part with a few changes that's up available on Blackboard along with our template for drawings that we use in 250, a real simple template that'll have this data right in the bottom right. And of course, that is available on Blackboard. So once you have the part downloaded, you should have this, and we're going to create the engineering drawing. So I'm going to go to File, and then Make Drawing from Part. Then here it's going to ask us for our sheet format and our template. And I'm going to assume you guys downloaded the template to a downloads folder. So I'm just going to show you how to get there. It's not going to be one of SolidWorks defaults. This is what SolidWorks comes with. Just going to hit Browse, go to my downloads, and then choose the ME250 CAD template. Hit OK, and then it's going to import our template, and then it's going to start by asking us to import some views of our part. So I'm going to start with this left one here. This is based on how I created the part, but really it's usually a front, right, and top view, but this is just based on how I drew it, and I didn't have this in mind when it was created, so we're just going to call this front, right, top, and then isometric. We always start with this standard 3-view drawing. So we've got all the angles we want. I'm going to go ahead and stop adding projected views. I'm going to select this. Just make hidden lines visible, and then the isometric one should always have these shaded edges. And then something I've just got in the habit of doing is making this high quality. It prints a lot better for quizzes and for reference. Before we go any further, I'm going to go ahead and edit this. So I'm just going to right click, edit sheet format, and then this is all going to disappear. And then we're just going to be editing our template itself. And these are just little text fields that you can just type in. So today's date, 10/29/2018, title, practice part 9, name, obviously that's your name, material, I believe this was cedar, units, we were in mmgs, and our scale, which we can talk about here in 1 second, we're doing 1:1. We can see in the bottom right here it says a sheet scale, and then we can change the scale in the drawings itself. So to get back to the engineering drawing, we can hit this right here, which will take us back to our drawing. So back to scale, we can stick with it in the bottom right. If we change it, you'll see it'll change the scale of the drawing. 1:1 was good. Or we can go click on the part, and it'll have a scale option here as well. 1:1 works out pretty well, so we're just going to go ahead and stick with that. So what we need to do, what is the goal of this? We are not going to get so in depth here in 250. We're not going to make ANSI or ASME certified engineering drawings. Our goal with these drawings is to be able to hand these off to someone and give them enough information to recreate the part. So the goal is, say you have this part and you want to go down to the machine shop and have our friend Gary recreate this for us, you'd be able to hand him an engineering drawing and he'd have all the dimensions he needs. We're not going to get too nitpicky on ANSI or ASME standards. We just want to be able to use this drawing to recreate the part. So with that said, it's probably best not to just go ahead and try and copy this one for one. What you want to try and do is, when looking at this part, look at it and know what dimensions you would need to recreate this part. Obviously, this is easier done when you created the part yourself, so you know what the dimensions are, but that's just a general rule to try and dimension only what you need to recreate the part. So that said, I'm just going to go ahead and get started. I'm going to start to dimension this thing out. It works just as it did in a part. We got our handy dandy smart dimension tool, and I'm just going to start dimensioning this thing out. So like the Linda video said, it's a good standard operating procedure to limit the amount of datum points we're using. So I'm going to try and record everything to like a bottom left point here. So to start, I'm just going to get this dimension out right here, this 35. And then something they don't really mention in the Lynda videos is this little feature right here, center dimension. I love to do it on all my dimensions. It centers this in the middle. I just think it makes it look a little bit nicer. But I'm just going to go ahead and continue dimension this thing out. So everything needs to have its space, just like we've learned all semester. See, that's not right. I'm going to go from here, this bottom horizontal line, from here to here. Maybe 55. And these aren't changing. You're not setting the dimension of the part. This has been done in the part document itself. Right now we're just kind of reiterating it. We did use the hole wizard up here, so rather than go through and give the specific dimensions of the hole wizard like this, we can use something like the hole callout. Click the hole and it'll give the data generated from the hole type that we used in the hole wizard. So just gonna go ahead, keep moving along. This should be fully defined up here. I'm gonna go ahead and start dimensioning this down here. Smart dimension from here to this point right here. Gonna go ahead and center it. And then all these share a midpoint, so I'm gonna go ahead and create a midpoint or a center line for this rectangle right here. Center line for these two edges, and it created this center line right here. That way we can only have to create this 17.5 once to show that all of these are sharing the same dimension. So we're good with that. I'm going to dimension out these two circles. That's going to be 4. And again, there are like ANSI and ASME standards of how to place these, their exact location, the amount of space to be between these. Again, we're just going for a general ability to recreate the part based on the engineering drawing. So as long as it's tidy and legible, we'll be good for everything we need in 250. So I'm just going to keep going along, dimension this part, everything we would need to be able to recreate it. So we've got the size of this, we're going to need its location in space. That's looking good. So now over here, I'm going to go ahead and create this part. I'm just going to show another way of doing some dimensions. I'm going to use the baseline dimension tool. Dimension from here, it's kind of a rapid way to add some dimensions. It's going to reference everything from here, and it just goes through really quickly and automatically creates the dimensions for you. I don't like this right here, so I'm just going to move that over. And now I'm going to do manual dimensions from this point here. Again, here to here. Really, it's just pretty much copying the dimensions you did in your sketch. So it's a lot easier when you made the part and you're making the drawing rather than getting a part that is provided to you. But the idea is you've already made this, so you should be able to either recreate it, then do the drawing, or just do it kind of from some memory of how you went about making it. So just recreating these dimensions. Oh, we've already got the 70 here. All right, on this, I made this section view. We're not really using it for anything. If we didn't have a whole standard, we could use the section view to dimension out some of our specifications on our whole. But I threw it in here anyway because it's good to have. So I'm just going to go ahead and show you how to create the section view. View layout right here in the top left, section view. Our cutting line kind of shows the direction we're going to cut. Where we're going to do it, I'm going to do it right here in the middle of the section line. And then I'm going to go ahead, it's going to name the section cut A. And then I'm just going to go ahead and click right here. And then this view is as if we were to cut right here and looking that way with the arrows. So this is pretty much done. We can just go ahead and go through and make sure we have all the dimensions we would need. We've got our whole call out. We've got the location of the point that we would use for the hole wizard. Got the depth of this part. We've got the location of the center points, their location in space, their size. Good, good, good. And then this, we have everything's size and location in space. So we should be good with this part. We've got our nomenclature and naming convention and our template filled out. I've got a section view created. It's not really referenced. I just wanted to show you guys how to create the section view. And we should be able to print this out, go downstairs, hand it to one of the machinists, and they should be able to recreate it for us. That's the goal of these drawings. If you are more interested in creating more workforce or professional drawings, feel free to look up ANSI or ASME engineering drawing standards. They're going to be a lot more in depth, and they could be an entire class on their own. But for this week, this is all we got for you. Hopefully it's not too hard. Thanks, guys.